Hey guys, welcome to this session on deep learning using TensorFlow in Python by Intellipaat. Deep learning is by far one of the most important concepts in machine learning, and it has been one of the most revolutionary topics that has made many things possible. Now, TensorFlow is one of the libraries that we can use to perform deep learning tasks, but what exactly is deep learning and how can you use TensorFlow to perform deep learning is what we'll take a look at in this session. Before we begin, we'd like to ask you to subscribe to our channel and click on the like button if you like our content, and comment down below if you would like us to do something else next. So with that in mind, let's take a look at the agenda. So we'll begin by taking a look at what are neurons. Since we are assuming that you don't have any background in machine learning at all, we'll try and demystify some of the core concepts of machine learning in general. Basically, we'll try and understand what neural networks are, and that begins with an understanding of a neuron. Then we'll take a look at what are artificial neural networks. So we all know that neural networks are the foundation of machine learning and deep learning in general. But what are artificial neural networks and how do they relate with the entire field of machine learning? Then we'll take a look at what are activation functions. They are a special kind of function that are really important for the functioning of our artificial neural network. Then comes what are neural networks. Now we'll take a look at what the activation function has done for us, and then we'll take a look at what are neural networks. And then finally, we'll take a look at what is deep learning. Deep learning is the concept that we'll try and demystify for you today. Once you get a basic understanding of all the concepts that we have expressed previously, learning a bit about deep learning is not going to be very difficult. Then we'll take a look at what is TensorFlow. TensorFlow is, as I've described, a library for deep learning, but what exactly is it and why is it useful? We'll take a look at that. And finally, we'd like to show you some hands-on using TensorFlow. We'll try and build a handwritten digit recognition model using TensorFlow. And with that, we'll like to show you how easy it is when you do it with TensorFlow. So let us begin. So firstly, what we take a look at is what are neurons. Now, if you have been studying biology for any number of time, if you have studied how the human brain works, the word neuron is something that you must have come across in any amount of times. So a neuron is also called a nerve cell, and these are cells that are responsible for receiving sensory input. Sensory input basically means when you touch something, you're receiving input from one of your five senses. When you touch something, when you see something, when you hear something, these inputs are transferred from your sensory organs to your brains, which is received by neurons, and these neurons are responsible for then converting these sensory inputs to motor commands to your muscles. Now you might be wondering, why is this important when we're trying to learn artificial intelligence in deep learning? Well, our neurons are the fundamental building block of a neural network. Each neural network is built on top of the concept of neurons. So neurons are by far one of the most important concepts that we need to have at least a basic understanding of what the biological foundation of a neuron is, so that when we jump into the actual machine learning neuron, we have some sort of a connect to understand what they are. In general, a neuron is basically just a cell that transforms sensory input to motor commands. So we'll just have to look at that in a moment. Now let's take a look at what are artificial neurons. We've taken a look at what are neurons, but how do they translate into artificial intelligence and machine learning? Well, an artificial neuron is an atomic computing system. It is vaguely inspired by the biological neurons, which we just looked at. That is one of the reasons why my biological neurons are given a forefront when we're trying to learn about neural networks. And these are used in artificial intelligence using machine learning. So just to give you a brief overview of what machine learning is, before machine learning, when we wanted to create computer software programs that could solve problems, what we would have to do is we would have to take the input, figure out how to transform it to the output, and write down rules that will do that for us. So if I take an input as an image and I want to convert it into a grayscale image, machine has no idea about the image, how the image is stored, what the numbers that are used underneath the hood to create an image mean. We as developers have an understanding of that. So our job was to write the code, which will use a lot of conditional logic, lot of looping, classes, objects, all kinds of constructs that we can use, and we transform the input to the output. Now, this is good for small kinds of problems, but for larger problems where we don't have any idea how this input can get transformed into the output, we have to use something called machine learning or artificial intelligence in general. What it does is that it takes the input, takes the output, in our case, our image, a colorful image and a grayscale image, takes a look at the input and output data, and it learns how to transform that input data to the output data. This is what machine learning in general does. It allows our machine the capability of drawing or learning things on its own, or inferring patterns that can transform an input to an output. That's basically machine learning. So that's what the foundational understanding of neural network is. A neuron, an artificial neuron to be precise, and an artificial neuron's job is to work as a biological neuron but in a mathematical context and convert input to output. Now, what do they do and how do they work? Well, an artificial neuron uses mathematics to model real world neuron behavior by taking input, performing weighted sum, using activation function, and producing output. So in neural networks, we basically have a network of a lot of neurons. So how does a neuron work? Well, a neuron has input. So in the input of neurons, we pass in some values. Those values are then multiplied by some weights. Don't worry about the values of those. We'll come to that in a moment. Then all those multiplied values are summed up. I've used 4 inputs, but you could have multiple inputs. This is just for demonstration purposes. Then they are transformed to an output using an activation function. Now, activation function is what makes this work. So let's understand what these are. So what are activation functions? This is a question that might have come across in your mind when we were discussing our artificial neural networks, or artificial neurons to be more precise. So in neural network, an activation function of a node is a function that takes the input from the node, which is weighted sum, and determines whether the input neuron should be fired or not. So to give you an example, if I were to take a neural network and if I were to take one neuron from it and I were to run that neuron with some inputs, whether or not that input should be activated basically means that whether or not that neuron would produce some output that would be helpful at a later stage. In neural networks, what we're doing basically is we have a lot of neurons that take input and then they determine whether or not they have the capability of processing the input correctly. And if they do, then they process it, and the activation function is what determines it from the output of the neuron. An example of an activation function would be ReLU, or rectified linear units. So it's very easy to understand these neural networks or activation functions in neural networks. They basically non-linearly transform our output of a neuron to a value. The range of the value is determined by the activation function. It could be from 0 to 1. It could be from -1 to 1 as well. Basically, when your neural network produces an output, if it produces an output that is less than a threshold value, then the output of the activation function will be 0. If it produces more than that, then it would be 1. And using this framework, neural networks then produce output with a whole number of values, and then we just determine whether or not they are going to be useful or not. The neural networks learn these things on their own, and we'll take a look at how that happens in a moment. Now let's take a look at what are neural networks. So neural networks are also called artificial neural networks and are circuits of neurons that are built to mimic biological network of neurons in human brains to solve problems using artificial intelligence. Now, this diagram that we have been showing you here is a very simple and very small contained example of what a neural network is. In reality, neural networks can be really large, really deep, really nested, and they would be really difficult to fit on a screen here, especially if we're trying to solve any problem that is meaningfully complex. So in this example, what we have is an input layer. It has 2 neurons. Then we have a hidden layer. It has 4 neurons. Then the hidden layer will produce an output, and that output is given to an output layer, which is 1 neuron. Now, I'd like to emphasize something here. The shape and the size of these layers and the number of layers is an arbitrary choice. So the input layer here has 2 neurons. That's not necessarily the case that every input layer should have 2 neurons. That depends on the kind of problem that you're trying to solve. As we'll take a look at in our hands-on, the kind of problem you're trying to solve, the kind of data that you have, determines the size, determines the topology of your input layer. Once that is done, once these input layers are fixed, then we move on to hidden layers. Now these hidden layers are basically layers that process the input and then based on the activation function move forward into the layers. So they will produce an output, and whether or not they were activated or not will make our next layer neurons fire, and that continues until the end. Here we have only chosen one hidden layer, but you could have multiple hidden layers. You could have tens or thousands of them. But this is going to be problematic if you have really deeply nested hidden layers, because then your processing would be quite slow. So you have to make sure that you understand the differences between speed and efficient training. We'll take a look at that in a moment as well. Finally, we have the output layer. The job of the output layer is to produce an output that could be understood by our model. And the output layer produces the output based on the data that we have. So if in our data we have output ranging from 0 to 9, which we will have in our data set, then it will produce output based on 0 to 9. Many times what happens is the output layer is same as the size of the input layer, and each neuron in the output layer gets a value from all the hidden layers. After that, we just have to figure out what is the highest value in the list of neurons. The neuron with the highest value is the neuron that is activated the most, which means this is the neuron that is the one we are supposed to use. So now let's take a look at what is deep learning. Now, since we have gotten a fair bit of understanding of what the neural networks and artificial neural networks are, deep learning is just a subfield of machine learning in which we make use of neural networks with very deep structures. And these deep structures basically mean that there are several hidden layers in order to learn from data and make predictions. So if you have some data and you want to create a neural network out of it, and that neural network contains an input layer and an output layer, and then there are a lot of hidden layers. This is basically what deep learning is allowing us to do. Deep learning allows us to create deeply nested neural networks, and because of the increase in the computing speed and power that we have, because of the advancements in cloud computing, in processing units, and in many other fields, we have been able to reach to a point where we can train our neural networks. Before this time, when the computers weren't as fast enough, to be able to train these neural networks would have been really difficult, as they are very deeply nested and they require a lot of number crunching and a lot of mathematical computation. In this context, however, since we have that ability to do that, it might take a lot of time, like 1 hour, 2 hours, 10 hours, 15 hours. We can spare that time because we have a lot of data and we have a lot of processing speed as well. So we can combine the data, combine the processing speed, and can produce a model that can produce the output. Now, these deep learning models are called deep learning mainly because of the deeply nested hidden layers. That's the entire point of calling it deep learning, because we have a neural network with very deep structure that is several hidden layers, or a lot of hidden layers, lot more than the ones that we use. Now let's take a look at what is TensorFlow. Now, TensorFlow is an open source library used for building and training deep learning neural network models. It was created by Google. So if you have ever come across the word TensorFlow, you use something called a TensorFlow library. This library is available in several languages, ranging from Python to Swift to even JavaScript, and there are mobile versions of this available as well. So all you have to do is choose a language in which the library is written in, download it, create a neural network structure, run the data through that structure, and the neural network will learn from the data and create a model. Then you have to basically take a look at what is the output, or what is the accuracy of the output that was produced. And we'll take a look at how we do that in a moment as well. After all of that is done, what we get is a model with the accuracy given to us. Now, if the accuracy is satisfactory, then we move ahead and deploy the model. If it is not, then we tune the model. After tuning it and checking the accuracy again and again, and this tuning is where we change the structure of the deep learning model, where we change the number of neurons, number of layers, number of neurons in each layer. What does each layer do, changing the activation function. This is not an exact science because we don't really know what kind of data needs what kind of structure of a neural network. However, there have been a lot of advancement, and we have been able to understand how to process images better using instead of using process images better using the things that we want to use, such as convolutional neural networks. If you want to process audio, we can use the LSTM neural networks, long short-term memory neural networks. And so we have been able to get some sense out of the data that we can use. But still, if we are trying to create a neural network out of some data, understanding the topology is where the entire creativity of building neural networks and deep learning lies. So With that, let's take a look at the hands-on. Now, TensorFlow has a lot of jargon associated with it. We're not going to cover all of that, but don't worry. We'll let you know one of the at the end of the hands-on. I'll guide you through some of the resources through which you can learn these things and also gain a really deep and good understanding of deep learning. So before that, let's take a look at TensorFlow. So if you are trying to follow along, you can. We recommend that you use Google Collab or Collaboratory. Now, Google Collab is basically a online Jupyter Notebook environment. Here, what you can do is you can create your own Jupyter Notebook and you can run it with the uh, code running in the Google Cloud Platform clusters, and it will work just fine. So to do that, the first thing you have to do is go to collab.research.google.com, or you can just search for Google Collab. If you have a Google account, you have to sign in and then you can start using Google Collab. After that, you click on File. It's taking a bit of time here. I'm not exactly sure why, but it'll happen in a few moments. When the file menu opens, we have to click on the new notebook option. You can open a notebook if you have already created one. This will be stored in your Google Drive, but I want to create a new notebook. The great thing about these notebooks is that they are created and we can use them on our own. We don't need to install any libraries. All of them are already installed. So they're great for prototyping as well as trying out new things. So I'll just change the name. And again, this will be stored in your Google Drive. TensorFlow Deep Learning. Now let's firstly import all the packages that we need. Now I want to use TensorFlow, PyPlot, and NumPy. So I'll just import them. So I'll import NumPy as NP. As you can see, I didn't have to install anything. That's mainly because in Google Colab, most of the libraries that we want to use for data science and machine learning are installed. Now import matplotlib.pyplot as plt. This is just a convention. You can just import pyplot as it is, but many people call it plt just for abbreviation's sake. And finally, we'll import TensorFlow as TF. Many people would use Keras instead of TensorFlow. That's completely your call. I run the cell. In Google Colab, just in Jupyter Notebooks, the code that we write are written in cells. These cells basically contain the code that we want to write. As soon as we run our cell, you can see that this changed from something to connecting. So it connected to a Google Cloud Platform server. That server is now running our code and it has been connected. So our code has run. If we had run into an error, we would have seen it here, but we didn't. Now it's time to get our data. I'll be using the MNIST handwritten recognition data. To do this, all I have to do is type MNIST equals to TensorFlow dot keras dot dataset. Keras is a library that comes with TensorFlow, and we have a lot of datasets here. I want to use the MNIST dataset. Now I want the training and the testing dataset. To do this, again, I have to I ran it here, but it doesn't really matter. Here I'll have to type in x underscore train. This will be the training dataset, and we have the y underscore train. Similarly, once we have gotten the x train and y train, we want another tuple that will contain the x test and y test. So x test, and you can call them anything you want. We are just calling them x test and x train because that's the most familiar way we do this. And now we use the MNIST object and use the load data function here. If I run this, it will show me that the data is being downloaded, and it will be downloaded in a few moments and it will be there for us. We don't have to worry about it at all. It has been downloaded. These are the number of values inside the MNIST dataset. Let's take a look at what the data contains. So I would like to plt dot, and I'd like to show you what the image contains. So these are just data points in image. In the image, I want to pass in two things, and you can see that Google Collaboratory is very helpful here. It's showing me that I have to pass in some data, and I can pass in a color map as well. So I'll show you what the first xtrain value is. And CMap, which stands for color map, is going to be gray, Gray. Now all I have to do is use the plt.show method to display it. If you've ever worked with matplotlib, this is very easy. If you haven't, just follow along and you'll see how I'm doing it. At the end of the session, I'll tell you about some of the resources. So this is the number 5. As you can see, this has handwritten. It's an image. It contains 28 by 28 pixels. Let me just show you what the data looks like. Let's take a look at the length of the xtrain function. So our training data has 60,000 values. The first row in our training data contains 28 values. If I were to show you what the training data looks like, this is what it looks like. And this is just some data about how 28 by 28 pixels look like, right? So if I were to give you the first row and I were to give you the length of the first row, it should also be 28 because our image is supposed to be of size 28 by 28, and it is. So this is what it looks like. So 28 by 28, if I were to show you, basically means 784 pixels. So for each image we have 784 data points. Each pixel can reveal something about our data. So now all we have to do is normalize the data first. So I'll just type xtrain is equals to tf dot. Tf again means TensorFlow, and inside it I have to use keras dot util dot, and here I have to pass in normalize. In the normalize function I have to just pass in xtrain and axis is equals to 1 because I want to normalize it uh, on the horizontal axis. And similarly I have to do the same thing for test. So this will normalize our data. Normalization basically means it will convert our data into being some not having outliers and all of that. Now time comes for building our model. Now building a model isn't supposed to be very difficult, and especially with TensorFlow we can build the topology of our model quite easily. To do that, firstly I have to create a model variable. Let me just go down. This would be TensorFlow dot keras dot. Keras is a library that comes built in dot, and it is going to be a sequential model. So this is how you can create a model. Now comes time to add layers to our model. So as I told you, there are many hidden layers to our model. This is going to be one of those. So I want to add a flattening layer. Tf dot keras dot layers dot flatten, and inside the flatten I have to new it up. So I will be adding 3 more layers just for the sake of it working, right? So I have a flattening layer, then I will have a dense layer, then I will have a dense layer, and then I will have a dense layer again. Let me just redo that again. So I have the dense layers. Let me just remove this one. Now these dense layers basically take in some value that tells us how long the value is going to be. We want to have 128 as the number of neurons here. Then this is arbitrary. Activation is equals to, and this is where we pass in the name of the activation function or the activation function itself. So tf dot neural networks dot, and I will pass in ReLU. Again, in the second one, I will also pass in the same thing, 128 and redo. Now the third one is going to be a little different. It's going to have 10 because this is the output layer and I want the output to be ranging from 0 to 9. So 10 values. And the activation is going to be softmax. This is what the output layer always have the activation of. So we have the softmax layer. Now if I run this, it should run in a moment. And we run into an error, multiple values of activation, because we did not remove 128. Now we run this and they should run in a moment, and it does. So we have gotten that. Now we just compile it. Compilation basically means we codify that everything is working and all the layers need to be added and we don't want to make any other changes to it. This takes in certain parameters. Optimizer basically is a function that will allow us to figure out what is the error and how we can correct for that. Then we have the loss. Loss basically means how the loss is going to be calculated, or the difference between the prediction and the output. So sparse categorical cross entropy is the one. SPARC, categorical and cross entropy. And finally we have to pass in the matrix, which basically means how do you want to calculate the functioning of your model. We'll use accuracy as the matrix. If I run this, this should run as well. It runs, and now comes time to fit our data. This is where we pass in the data that we want. It's the fit function that takes in training data, testing data, and epochs. So x is equals to x train, y is equals to y train, and epochs is equals to 5. Epochs basically means how many times do you want to train it. Training it for more times gives you more accuracy, but it takes a lot more time as well. So if I run this, it will give us the output. We got an output. Received 32 should be equal to 1. Let's see. So we got the x train, we got the y train, and the epochs are supposed to be 5. So the error that we are getting is the shape mismatch, which basically means that we have gotten the we have incorrectly classified our data. Let's see. So we have Adams and accuracy. Then we have the sequential layer, and we forgot to flatten our layers. That's the problem. So we had by mistake forgotten to add our flattening layers. So instead of this, we do it this way. Now we run this, then we run this, and then we run this. Now it should work. Now the output that it is producing, as you can see, it's running it for multiple times. It's training them, and in each training per step, it's making some changes into the internal structure to figure out what's the best step. If we let it run for a longer time, it will give us a more better output. Now that that is done, what we can do is we can take a look at the test loss and test accuracy. So I'll just take a look at that. This tells us how accurate is our model based on the training that we have done. Test loss and test accuracy, we are going to use the testing data by using the model.evaluate function that will take in x and y variables, in which x is equals to x test, y is equals to y test. Run this, it will run. Everything is done. Now all we have to do is make the predictions, print the accuracy firstly. So let's just test loss and test accuracy. So where accuracy is 95.8%. Now if I want to make a prediction, let's say we want to make the prediction for the 1000th value in our data set. So to do this, all I have to do is just make the prediction using predictions is equals to model dot predict xtrain, or we can take, instead of xtrain, we can take the xtest because it's smaller, it'll work faster. And now all I have to do is print the numpy dot argmax argmax. Inside it, it'll take the predictions, and I want the 1000th one. Let's see the prediction. It makes the prediction of 9, and if I were to just go up a bit, this is where I did it. I'll go down again, and here instead of showing the zeros value, we'll take a look at the image that it makes the prediction of. And x test, I have made a mistake. It should be x test. It should be 9, and it is 9. So our predictions are working correctly with the accuracy of 95%. As you can see, it's really easy to build the model. We have done it in around 20 lines of code, which is quite remarkable. Now, with the hands-on out of the way, I'd like to give you some of the resources through which you can learn these things and get a better understanding of it. So one of the best quotes when I try to learn something new that keeps me inspired is, an investment in knowledge always pays the best interest. With that in mind, we have our own community site which you can use in order to get answers to the questions that you have, where like-minded learners like you can ask questions and get the answers. We also have a blog, intellipaat.com/blog, where you can go and take a look at the content that we have written up so that you can learn. If you're more of a visual person, our YouTube channel has a lot of content for you to consume. We have free courses available on our YouTube channel for you to learn from. If, for instance, for some reason you are not comfortable with all of this and you want to learn and master your skills, we recommend our Masters in Artificial Intelligence course. It teaches you everything that you need to know in all the languages that are currently the norm. We learn data science with R, with Python. Then we take a look at machine learning, deep learning with TensorFlow, which was the point that we had here. Then we take a look at natural language processing, advanced deep learning and computer vision. And then you have self-paced trainings here as well, where you can learn SAS, Excel, and Tableau for data analysis. It's one of our highest rated courses. It's a master's program. We provide you with 9 courses and 22 plus projects so that you can get a hands-on experience and you have something to show to your potential employers, and you have 166 hours of content. Now, if you go down, you can take a look at the course that's available to you. You can take a look at an overview of what will be taught to you. You can take a look at the testimonials. As it's one of our highest rated courses, you can take a look at the testimonials. They are mostly good. We have data science, Python, machine learning, and all the courses that we have told you. You can take a look at the curriculum as well. This is accredited with IBM, so you'll get a certificate from IBM as well as a certificate of completion from us as well. These certificates are important, as when you try to apply for jobs, they'll tell you whether or not you are eligible for a particular role by taking a look at these certificates, because they will prove that you know what you're talking about. Finally, if you have any questions, you can use our FAQ section. This contains most of the frequently asked questions that you can come across when you are trying to learn these things. In case you are not finding the answer to your question here, let me just tell you where you can go. So just before we end our session, thank you so much for joining us. Hopefully this has been fruitful to you. You can take a look at our courses and buy them with a flat 30% off using the YouTube 30 coupon code. Now, this is especially for the YouTube viewers. This offer is not going to last for very long, but you can take advantage of the YouTube 30 coupon code right now. Now, if you are still worrisome and you have some questions that are not answered in the FAQ or anywhere else, take a look at these numbers and you can contact us. And our contact team will take a look at your queries and will try and help you as much as possible. We have number for India, US, we have an email if you're not more of a call person, and our course advisors are there to talk to you 24/7. So at any time, if you wish to have some chat about getting better at a certain technology for betterment of your future, for betterment of your career, you can call us at any time. With that, we'd like to part ways. Thank you so much for joining us. Hopefully this has been informative to you. If it has been, click on the subscribe button, click on the notification bell icon, click on the like button if this was useful to you, and comment down below what you would like to cover us next. Thank you so much.